we are learning about the phrase differentiable. A few things that we need to understand before we talk about differentiable. First is left-hand derivative. It is denoted by L, f prime of, instead of x, we are taking a particular point C. So we're looking at left-hand derivative at a point C, at C basically. So it will look like this: limit f of, in place of x, we are putting C plus h minus f of C. This entire thing divided by h, as h tends towards 0. Now, similar idea at your right hand, or f prime of C will be equal to limit f of C plus h minus f of C, this entire thing divided by h, as h tends towards 0. So what is the difference between this and this? Well, over here we need to add a negative and here the symbol positive, just like your limits, left hand limit and the right hand limit, approaching from the left hand and approaching from the right hand. That's it. It's the same idea, just that it is in case of your derivatives. That's it. Okay, and now you guys can guess differentiable at a point. What does it mean? A function f is differentiable at a point C in its domain if both of this left hand and the right hand derivatives are finite and equal. So basically these two are not infinite and they are equal. Now, if we understand the differentiability at a point P, we will be able to carry this idea over to your open interval and closed interval. So open interval, say this is your graph. This is after differentiation, right? This is the graph of I'll need it one more. Yeah. So this is open interval. So that's your f prime of x and this is x. So you take any point, we need to be able to satisfy this condition. That's it, as simple as that. So this is differentiable in an open interval. While in a closed interval, there's an extra condition. This is f prime of x. This is x along with a and b. Here a and b are not included. Here along with a and b, every other point between them are included. So if this is said to be differentiable, right, the function is said to be differentiable in an closed interval, same as before, we need to be able to take any point and show that left hand derivative is equal to right hand derivative. But when it comes to your closed interval, along point a and b, this are the condition. So for a, we have f prime of a, that should be finite and it should exist. And for your b, from the left hand side, the derivative should exist. It should be finite basically. So then the function is said to be differentiable throughout a and b, including a and b. It's the same idea as limits. It should not be too hard. Okay guys, so please copy it off. It's not that hard. It's a carryover of previous ideas.